I needed a high DC voltage to power the electrostatic motors, which were the subject of two other videos, the Franklin Bell's video and the rotary electrostatic motor video. So I constructed a Van de Graaff generator to produce about 10,000 volts DC. So I'm going to describe how to construct that Van de Graaff generator and how it operates. These are the only parts that are needed to do that. I have a soda can with the top cut out, and that is what's going to charge up to 10,000 volts. Two AA batteries are the power source. There's some PVC tubing with some wire connections, which I'll describe in a minute. There's a simple motor, a rubber band, a glass tube, and you can use a nail, something that the glass tube can rotate on. And so what's going to happen is the electric motor is going to turn the rubber band, and the tension between the rubber band and the glass tube will have the glass tube and the rubber band rotating. And on the motor axle, I've wrapped some Teflon tape, and what you want to do is crown the pulley so you have a little bit of a bulge in the center. And what that will do is that the rubber band will center itself on that bulge and it won't walk off to one side or the other, so that's important to do. The other thing you want to do is take some isopropyl alcohol and clean everything down, because trying to get to these high voltages, anything on the surface that is conducting will hurt obtaining the high voltages. And there's also this little base here. This piece is going to hold the motor, and I've drilled a hole here and put a wire through it, and you can see that I've frayed the wire a little bit here. The motor, I've wrapped a little bit of electrical tape so I can get a fairly snug fit in here. On this piece I've drilled some holes, so this hole here is so that I can put the wire through with the frayed edges, and at right angles to it I have holes drilled, and what I will do there is I will put the glass slide on this piece of metal, which could be a nail, and the glass slide will be able to rotate on this. So now let me put the three pieces together. So now I'm going to insert the rubber band. And now let's insert the motor. So now I have the rubber band around the axle of the motor, and I'm going to now attach it to the base. Okay, now at this end I want to insert the glass on the nail or piece of metal I have here so that the rubber band will go across this axle. Okay, so I'm going to pull the rubber band out, put it over the glass tube, and now slide the metal rod through, and there you have it now. I will now attach the battery to the motor. And you can see how the rubber band is turning now on the glass tube. The wire that comes through in the top here, you can see how it's frayed edges are pointing towards the rubber band, and it cannot be touching. It's about 1/8 to 1/4 of an inch away. Also, on the other end, we have the other wire that's coming through, and it's frayed, and again, it's not touching the rubber band on the bottom by the axle on the motor. It's about 1/8 of an inch to 1/4 of an inch away. So this piece of cardboard I'm going to put over the top here, and it's just sort of a base for the soda can. Okay, so now I want to make an electrical connection to the inside of the soda can to this top wire. And so I'm going to just tape the end of the wire to the inside of the soda can here, and then place it on top of the cardboard. So here's our completed Van de Graaff generator. So the wire that's on the bottom here, I will ground, and then when I attach the power supply to turn the motor, this can will charge up to about 10,000 volts. I've attached some strips of aluminum foil to the can, so when I turn on the Van de Graaff generator and it charges up, the aluminum strips will charge to the same potential as the can and be repelled from the can. And when I bring my finger in, I'll get a momentary discharge of the can. You see the strips collapse and then they come right back. I'm going to turn on the Van de Graaff generator and let it charge up, and then I'm going to bring my finger in and see how close I get before I get dielectric breakdown between my finger and the can. Now, the dielectric breakdown strength of air is about 10,000 volts per centimeter. So if I'm building up a voltage of 10,000 volts, I should get a spark when my finger is about 1 centimeter away from the can. This is an illustration of our Van de Graaff generator. Here is the rubber band, the motor axle, and the glass tube axle. And the glass tube and rubber band and the motor axle and rubber band are actually in contact, but I'm showing a little gap here. Here is the soda can. The soda can is actually sitting above the rubber band in our actual Van de Graaff generator, but I put it over to the side here. Here are the two wires. The first wire here are the frayed end, and you can see it's in close proximity but not touching the rubber band, and it is grounded. And the top one is contacting the inside of the soda can, and here's the frayed end, again not contacting the rubber band. You don't want it to contact the rubber band because you can scrape some metal off of the wire onto the rubber band, making it conducting. And we want the rubber band to be very insulating, and that's why earlier I said you want to clean everything with isopropyl alcohol to make sure there's no conducting material on the surface of the insulating materials. And you can get isopropyl alcohol at any drugstore. It's listed under the name rubbing alcohol. When we turn the motor on and it starts turning, the contact with the rubber band will cause the rubber band to start moving, and also the glass tube will turn as it's making contact with the rubber band. Now, when rubber touches glass, there's a transfer of electrons from the glass to the rubber. So the glass will start charging up positively, and the rubber band will start charging up negatively. Now, because the surface area of the rubber band is much greater than the glass tube, these negative charges on the rubber band will be spread out. Okay, so now this wire, which is in close proximity, will see mainly a strong positive charge in this area because the surface density of positive charge on the glass tube here is much greater than the surface density of negative charge on the rubber band. And so electrons will be attracted to the tip of these frayed wire ends here, and we'll actually have a very strong electric field in this region. So let's zoom in on this region and see what's going to happen. So the electrons will be attracted to the tips of these wires, and there will be a very high electric field here, and electrons will get emitted from the tips of the wires. And then they will attach themselves to air molecules such as nitrogen and oxygen. So when these ions form, they're negatively charged and will be repelled from the negatively charged wires here and be pushed to the rubber band, where when the, say, oxygen ion hits the rubber band, the electron will be deposited on the outer wall here. So the electrons that are attracted to the tips here will leave positive charges behind. And we know that when we have a conducting material like this can, those positive charges will want to get as far away from each other as possible, so they'll go to the outer edges of the can. And as we lose electrons from them being emitted from the wire tips here, those electrons will travel on the outer edge of the rubber band, and so we'll get a continuous movement of electrons from the wire onto the rubber band and a continuous increase in positive charge on the outer wall of the metal can. Now eventually this process would stop once the electron density gets high on the outer part of the rubber band, but that is what the lower wire to ground is. We'll have the same effect occurring here. Let's zoom in then on what's occurring at this bottom wire near the rubber band. The electrons on the outer surface of the rubber band will repel electrons in the wire, and so the tips of these wires will become positively charged. And because of the low radius of curvature, there will be high electric fields in the region of the tips, and so the oxygen and nitrogen molecules near the tips in these high field regions can lose electrons to the wire and become ionized. So these positive ions then will be repelled by the wire and attracted by the electrons here. When these ions get to the surface of the rubber band, they will then acquire electrons and become, again, neutral oxygen and nitrogen molecules, thereby removing electrons from the surface of the rubber band. So the Van de Graaff generator is transferring charge from our metal can to ground. So it's continually taking electrons off the can onto the rubber band and then onto the bottom wire to ground, and this continuous pumping of charge of electrons off the soda can is increasing the amount of net positive charge on the outside wall and eventually getting to the 10,000 volts that we demonstrated with our Van de Graaff generator we built.